let A is equal to the matrix 0, 0, 1, 0. Show that AI plus BA power n is equal to A power n into I plus n into A power n minus 1 into BA, where I is the identity matrix of order 2 and n belongs to n. So we have to show that AI plus BA whole power n is equal to A power n into I plus n A power n minus 1 into B into A, where A is the given matrix which is equal to 0, 0, 1 and 0. Also I is the identity matrix of order 2 which is equal to 1, 0, 0, 1. Equation we prove by mathematical induction method. So first we have to prove for n is equal to 1. So that means we have to prove the LHS is equal to RHS for n equal to 1. Substitute n as 1 in the equation. We get AI plus BA whole power 1 is equal to A power 1 into I plus n is 1. So A power 1 minus 1 BA. So we get AI plus BA is equal to AI plus, we have A power 1 minus 1. 1 minus 1 is 0. So anything power 0 is 1. 1 into BA is BA itself. So we got LHS is equal to RHS. So therefore we can say it is true for n equal to 1. Let us consider it is true for n is equal to k. If it is true for n equal to k, directly we can say AI plus BA whole power k is equal to A power k I plus k into A power k minus 1 B into A. So now we have to prove it is true for n is equal to k plus 1. So replace n as k plus 1. We get AI plus BA power k plus 1 is equal to A power k plus 1 I plus k plus 1 A k plus 1 minus 1 B A. So we have to prove LHS is equal to RHS. So consider only the LHS. So consider AI plus BA power k plus 1. So expand this as AI plus BA whole power k into AI plus BA power 1. So that bases are same, we can add the powers, we get the same LHS. This is equal to, so we got an equation for n equal to k. Substitute here. So this will be equal to A power k I plus k A power k minus 1 BA into AI plus BA. Now multiply these two brackets. We get A power k I into A power I will be A power k plus 1 into I into I is I square plus k A power k BA into I plus A power k I BA plus k A power k minus 1 into B square into A square. This is equal to A power k plus 1 I square is I itself plus, from these two equation we can say k plus 1 into A power k B A into I. Since in both the case we have A power k B A I as common, so I have taken common. So we left with k plus 1 plus k A power k minus 1 b square into a square. So we have a squared term. So first find a square. So call this as equation 1. Let me solve for a square. A square is equal to a into a, where a is the given matrix, which is 0, 1, 0, 0 and 0, 1, 0, 0. So on multiplying this, we get 0, 0, 0, 0 is equal to, this is a null matrix, so this is equal to 0. If a square is equal to 0, this a square into terms of this a power k minus 1 b square will become 0. So 0 into anything is 0. So we left with ai plus bk power k plus 1 is equal to a power k plus 1 I plus k plus 1 a power k ba into I. So a matrix into identity matrix result with same matrix plus 0. So the 0 is neglected. So this is our RHS. So we proved LHS is equal to RHS. Therefore it is true for n is equal to k plus 1. So therefore we can say ai plus bk power n is equal to a power n into I plus n into a power n minus 1 into ba is true for all n which belongs to n, hence proved.